Hi guys, welcome back to my YouTube channel. If this is your first time, please like, share and subscribe. And also drop any comment on any topic you'd like me to expand on, or anything I say here that you don't really understand. Just drop a comment so that I can make a video about that. Thank you very much. Now, if you recall, we stopped at domain of the function in the last video. Today we want to look at how we can still find domain of some other functions. So we still want to look at how to find domain of some other functions. Now, the last time we looked at how to find domain of a rational function, and I told you for a linear function or a quadratic or cubic function, the domain is the set of real numbers. That one is very clear. But for a rational function, if you're told to find the domain, you have to play around with the denominator of the function. Now, let's look at a function like this. We have a function that is still rational, a rational function, but this time around the denominator is not linear. It's a cubic expression, it's a quadratic expression. So I have, let's say, 4x squared plus 3x minus 2 all over x squared minus x, then minus 6. You have that kind of function, and you're told to find the largest domain or the domain of the function. How do you find the domain of the function? Now this function is still a rational function, even though the numerator is a quadratic expression and the denominator is also a quadratic expression, but it's still a rational function. So the same concept we applied in the last video to the rational function is the same thing here. What do? Take the denominator and equate it to 0. So we'll take our denominator. What's our denominator? X squared minus x minus 6 equals 0. Equate it to 0 and solve for x. If you solve for x, those are the values of x that will make your denominator to be 0. And recall I said, if your denominator is 0, that means you are not going to have an output value, meaning that that function will be what? Undefined. So now, how do you solve for this? If you have a good calculator, you can solve it with your calculator. But let's solve it manually and see. So solving it, let's use the factorization method. How do we factorize this? If you still recall, you have to multiply the first term and the last term of your quadratic expression. Now the first term is x squared, which is your quadratic term. Then minus 6 here is our constant term. If we multiply the two of them, what do we get? We get minus 6x squared. So we are now going to look for two numbers that are factors of 6, that if we multiply them together will give us minus 6. But if we add them together, it will give us minus 1, which is the coefficient of x here. The coefficient of x is minus 1. So two numbers that if you add them together will give you minus 1. If you multiply them together, it gives you minus 6, which is the coefficient of this product. So what are those two numbers? Can you think of any? Yes, it's what? Minus 3x and what? Plus 2x. Minus 3x and plus 2x. So if you combine the two of them, if you multiply, look at this, minus 3x times 2x, what will you get? Minus 3 times 2, that's minus 6. X times x is what? X squared. If you add minus 3x plus 2x, what do we get? This will give us what? Minus x. So these are the two factors that we need. So in factorizing, what you do is you have to replace the middle term, which is your linear term, with the two factors that you have. So we are going to replace this linear term. Instead of putting minus x, we are going to put minus 3x, then plus 2x minus 6 equals to what? 0. That's what we do. Now from here, what do we do next? You are going to factorize them in pairs. So factorize the first two terms and factorize the last two terms. You're going to factorize them in pairs. So if I factorize this, what do they have in common? Factorization simply means take out what they have in common. Look at what they have in common and pick it out. So what do they have in common? There's x here to power 2 and there's x here. They have x in common, so I can pull out x. If I pull out x, what will be left here? This is x squared. X squared means x times x, meaning there are 2x there. X times x. So if I remove 1, how many will be left? 1 will be left. Minus 3x. If I remove x, what will be left? Minus 3 is left. So we have minus 3 there. Then plus. What does this two have in common? There's x here, there's no x here, fine. What about, look at, there's 2 here, there's 6 here. Is there a number that can divide 2 and 6? Yes, there's a number. What's that? 2. So 2 is common there. So if you factor out 2 here, factoring out means if you divide 2x by 2 here, if you divide 2x by 2, what will be left? X minus, divide 6 by 2, what do you have left? 3. And this will be equal to 0. Now take note that for every factorization, if you factorize properly, at the end of the day, the terms inside the bracket should always be the same. They will always be the same. They will be the same in all sense, in the sense that even with the signs are the same. Not the one that you have minus here and you have plus here. If you have that, they are not the same. So they must be the same. And if they are the same, it means you are doing the right thing. So from here, I can now pick what is here, x plus 2, then pick one of the bracket, one of the terms. X minus 3 equals to what? 0. That's what you have. From here, to get my values for x, I will now apply a principle in maths called zero product. Zero product principle. What does zero product principle mean? It says that if you are multiplying two numbers, a times b, and it's equal to 0. If you multiply two numbers and you get 0 as your product, it means that either one of the numbers is 0 or the two numbers is 0. Because it's not possible for you to multiply two numbers and it just gives you 0. If one of them is not 0, the two of them is not 0. It's not possible at all. So for you to multiply two numbers and get 0, it means one of them must be 0. So it's either a is 0 or b is what? 0. So this is a zero product principle. Zero product principle. So that's what we apply here to get our values for x and y. So what we do is, our values for x. So what we are going to do now is take the first term inside the bracket, the first bracket, x plus 2 equals 0. Or the second inside the bracket, x minus 3 equals 0. From here, what do we get? It means our x, what you do is, for you to eliminate this plus 2, what do? You subtract 2 from both sides. You subtract 2 from both sides. That is x plus 2 minus 2 equals to 0 minus 2. And that will give me x plus 2 minus 2, that's 0. So that will be left with x. 0 minus 2 minus 3. Then you come here, I have x minus, to eliminate minus 3, you add plus 3. We call that additive inverse. Additive inverse. So if I have a number like 3, if I want to eliminate 3, I use the additive inverse of 3, which is what? Minus 3. If I have minus 3, the additive inverse of minus 3 is what? 3. So the additive inverse of minus 3 is plus 3. So I'll do minus 3 plus 3 equals to 0 plus 3. Minus 3 plus 3 is what? 0. So I'll have that my x will be equal to 3. 0 plus 3 is 3. So it means that my x is equal to minus 2 or x is equal to 3. So meaning that these are the two numbers that if you impute into this function, it will give you what? 0. In the denominator. And if your denominator is 0, it means that this function will be what? Undefined, meaning that it won't have any output value. So we are now going to write our domain. We're going to write our domain now as x, such that x belongs to the set of real numbers, comma, x is not equal to minus 2 or 3. That's our domain. Or you can say that the domain is all real numbers except minus 2 and 3. All real numbers except minus 2 and 3. So that's the domain of this function. It's as simple as that. Then I also talked about functions that have roots. Functions that have roots. So domain of functions with roots. Functions with roots. Functions with roots. For example, we have a function as such that x is assigned to square root of 3x minus 2. We have this kind of function, and they tell you find the domain of the function. Now, one thing you should take note is that if you pick a calculator now and try to find the square root of any negative number, the square root of any negative number, it will tell you math error. What does that mean? It means that you cannot find the square root of a negative number. You can only find the square root of what? Positive numbers. From 0 to positive infinity. Those are the only numbers you can find their square root. You can find the square root of 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 2 is 1.4 something. Like that. But you cannot find the square root of minus 1. In fact, square root of negative numbers gives us another set of numbers called complex numbers, which I will not mention in the set of numbers I listed. If you notice in the first video, I mentioned some sets of numbers. If we should go through them again, we have whole numbers or natural numbers, which I said there's a difference between them. Integers, rational numbers, irrational numbers, real numbers. Now there is another set of numbers called complex numbers. And that complex numbers comes from what we call an imaginary number, which has to do with the square root of negative numbers. So because of that, we'll just ignore that. We'll discuss it in another video. But looking at this now, if you're finding the root of any number, if the number is a negative number, you cannot find the square root of such a number. So that also implies to our function. If we are to find the domain of this function, it means that we are going to find it's only the values of x that will make this particular expression inside the bracket to be positive. Any value that will make this expression to be negative cannot be part of our domain. For example, can you think of a value that if we substitute for x here as our input value, this function or the expression here will be negative? Can you think of any number like that? Let's say a number like minus 1 or even 0. Minus 1 is 0. If my x is minus 1, look at it. If my x is minus 1, then my image will be f of minus 1. What would that give me? That would be square root of 3 times minus 1 minus 2. And that will give us square root of minus 3 minus 2. That will give us square root of what? Minus 5. Square root of minus 5. Can we find square root of minus 5? Of course you cannot. If you use your calculator to try, you can try with your calculator. It will tell you what material. So meaning that you can't find square root of negative number. Hence, so we have to find the values of x that will make this particular expression under the root sign to be what? Positive. That is how we get our domain. So how do you do that? It's simple. What you simply do is pick the expression under the root. Pick the expression under the root and make it greater than or equal to 0. Because you're going to have a range of values. It's not just going to be one value. You're going to have a range of values. So what I do is to find the domain of this particular function, I'll pick what I have under the root, 3x minus 2, make it greater than or equal to 0. Make it greater than or equal to 0, you have 3x. Okay, by the way, this is inequality. And some students have issues with inequality. But I want to assure you that the way you solve an equation is the same way you solve an inequality. The same way you solve inequality is the same way you solve this equation. So in this case, now, what you have there, to solve this particular problem, the same way you solve an equation is the same way you solve it. So what do? First thing is eliminate this minus 2 here. How do you eliminate the minus 2? You are to use the additive inverse of what? Minus 2. And recall, what's the additive inverse of 2? A number that if you add to minus 2 will give you 0. So what's that number that if you add minus 2 plus 1 will give you 0? You guess it correct. The answer is what? 2. So you have to add 2 to both sides of the inequality. So I have 3x minus 2 plus 2 greater than or equal to 0 plus 2. Now from here I have 3x minus 2 plus 2 is what? 0. So I have 3x is greater than or equal to what? Greater than or equal to what? 2. Because 0 plus 2 is 2. Now from here, how do I make x tangible? You divide both sides by 3. Dividing both sides by 3, you have 3x divided by 3 greater than or equal to 2 divided by 3. 3 and 3 will go. This implies that my x is greater than or equal to 2 over 3. So from here now, we can now get our domain. What is our domain? Of course, you can see my domain will be equal to x such that x is a real number and x should be greater than or equal to 2 all over 3. All numbers that are greater than or equal to 2 all over 3. So 2 all over 3 is included as well. Because if you substitute 2 over 3 here, you're going to get what? 0. And you can find the square root of 0. So all numbers from 2 all over 3 to positive infinity. That makes up our domain. So this is it. Now, the next one I want us to look at is domain of logarithm function. Logarithmic function. For example, majorly for IGCSE questions, most of their functions there could be a logarithm function. Logarithm function. And you have to find the domain of such a function. Let's say, for example, let me say functions, logarithm functions. Logarithmic functions. How do you find the domain of such a function? So, let's say you have a function like this, f of x, which is equal to 4 ln 3x, or let me use 2x plus 3. You have this kind of function. You have to find the domain of the function. How do you find the domain of this kind of function? Look at this symbol. Ln. This is called ln. Ln. It's a special type of logarithm called natural logarithm. Natural logarithm, or logarithm to base e, or logarithm to base e. Natural logarithm or logarithm to base e. So if you've seen anything like this before, log of x to base e. Log of x to the base e is the same thing as saying ln x. This thing here, ln, natural logarithm. That's what it means. So if you have a function like this and you're told to find the domain of such a function, like I said, this is majorly, this kind of questions you see majorly in IGCSE and issue of math. You're told to find the domain of this kind of function. So how do you find the domain of the function of this nature? Now let me tell you this. One of the properties of logarithmic function is that for a logarithm, the domain of a logarithm function is always a positive real number. The domain of logarithm function is positive real numbers. What does that mean? It means that if you're finding the logarithm of a number, by the way, how does a logarithm function look like? A logarithm function has two components, majorly. Log of x to base a. A logarithm function has two components. The first component is this, the second component is this. This is called the argument of the function, and this is called the base of the function. So a logarithm function has the argument and the base. So now, when we are talking about a logarithm function being, the domain being positive real numbers only, it means that the argument of a logarithm function can never be negative or zero. It cannot be negative and it cannot be zero. It's only positive. Only positive. It cannot be zero, it cannot also be negative. So you cannot find the logarithm of a negative number. You cannot also find the logarithm of zero. You can only find logarithm of what? Positive numbers from 0 and above, but 0 is not included. Are we together? So take note, 0 is not included, meaning that your argument here can only be positive. So that knowledge can help us to find the domain of what? A logarithm function. In this case, natural logarithm for the natural logarithm of 2x plus 3. So if I'm to do this now, I want to find the domain of this function. So how do I do that? Pick the expression you have in the parentheses and play around with it. That's what you have to do. So you have to pick what is the value of x that will make this guy to be negative or 0. So we have to make sure that all the value of x we have to get will not be what? Negative or 0. So how do you make sure of that? You just say 2x plus 3 greater than what? 0. Greater than. If you notice, it's different from the one when we had the root sign. When we had the root sign, it was what? Greater than or equal to 0. Meaning that 0 was included. So you can find square root of 0. But in this case now, 0 is not included because you cannot find the logarithm of 0. So now you make it strictly greater than 0. Now in this case now, you are going to have, we have to eliminate 3 so that we can find the value of x. So to eliminate 3, we use the additive index of 3. And what is that again? Minus 3. So this will give me 2x plus 3 minus 3 greater than 0 minus 3. So we subtract 3 from both sides. This will give us 2x. This is 0. Is greater than minus 3. 0 minus 3 is minus 3. From here, you divide both sides by 2. You divide both sides by 2, you have 2x divided by 2 is greater than minus 3 divided by 2. This will give me x, because 2 and 2 will go, is greater than what? Minus 3 over 2. So, your domain now. The domain of this particular function now, domain, will be equal to x such that x is a real number, x is greater than minus 3 over 2. That's my domain. So this is how to find domain of different functions. Now, someone might ask, or you might ask, how do I find the range of the function? If I found my domain, how do I find the range? And please don't forget, what did we say is domain? Set of all possible inputs. So how do I find the range if I found my domain? Now, to find the range of the function, that would be, before we can find the range of the function, we need to know how to find something else, which is what? Inverse of the function. So to be able to find the domain of the range of the function, after knowing your range, your domain, to find the range of the function, you need to know how to find inverse of the function first before you can find the domain of the function. So don't worry, when we get there, you're going to learn how to find the range of the function.